Hi, and welcome to a brand new video. Today we're going to be tackling the problem in which we have an array, and between two high points, we can trap, in quote, rain in between them. So for example, between here, we can trap one, I guess, I don't know, like 1 pixel or something, one drop of rain. So we need to see how much we can trap. So, in order to solve this problem, what we're going to do is we're going to first obviously create, um, or I think ans is the better word, and just return ans at the end. So ans is the number that we're going to be tracking how much rainwater we can store. As you can see here, I think the best solution here would iterate through the array. And then once we reach a particular point, let's say this one right over here, we're going to iterate through the left and see the highest number. And then we're going to iterate through the right and find the highest number. And then we're going to because we want to store as much rain as possible. So we can, if there's a really high number, we can store that much rainwater in between those. So next is after finding those, we can find the min height or the min number between those two. So for example, if we iterated through here, we can see that 1's the max and 3's the max. So we'd have 1 and 3. So we find the min of them because if you're building, let's say, a well or something, you can't have one wall be like this and then the other wall be like this and store water up here. It's gonna fall over. So we want to take the minimum and then that's going to be how much rainwater we can store. So what we're going to do is we're going to say for int I equals 0, I is less than height, dot length, I plus plus. We're going to set in left max and in right max. And then we're just going to iterate with j. J is less than height of height dot j is equal to I. J is less than equal to height dot length and j plus plus. So and not equal to. So this is for right max. We can say right max is equal to max dot max of right max and height of j. And then we can do the same thing with left max. So we can say for int j is equal to I, j is greater than equal to 0, j minus minus. We can say left max is equal to max of left max and height of j. And then lastly, we need to set the answer here is will plus equal math dot minimum of length dot left dot max and right dot max, like we talked about in the problem here. But also, we also need to consider the current position. So here, the current position is 0, but let's say we're at this 1 here. So well, that's not a good example because you can't store any. If you're over here, then, oh, that's not a good example either. If we're on this 1 over here, so we have 2 the max here and 3 is the max here, so that'd be the water here. But over here, no, 1, that's our current height. So you can't store water below the current height. So what you'd have to do is you'd also have to subtract the current height. So that'd be height of j. Oh, sorry, height of I. And the reason this works is because at this particular spot, you can store up to this height. And you don't have to consider about this portion because we considered that earlier in the array. And you don't have to consider that like this portion because we'll consider that later. So now all we are doing is seeing how much water should be stored in this specific column. So now if we run this, I just pulled out 2 examples. You can see here that the answer is 6 and 9, and you can see here on the sheet here we have 6 and 9. So hopefully that helped you solve this problem, and see you in the next video. Bye!